100%. Oh, sorry, so, what's the news report? So this date is the 7th of February. This is 6. So we're gonna watch this video. We're gonna watch this now. But we're gonna read it around. We're gonna read it around. So this will start. Yes. So basically, I'm claiming that the second. Basically, I'm claiming that the lava lamps insecure still because the randomness, yeah, the movement of the lava lamps in the lava have a motion, but that motion is basically like a crystal too. The capital of the motion is a static system, and it's still static because they're still in a static position. So if over time to get a definition, you don't have to really know too much about the system to hack it. You just need to know that it comes stochastically the strength and different ratio. If you have stochastically means the pattern is random, yes, but it's distributed randomness. It's a pattern that's distributed in a random fashion. It doesn't mean stochastic. Basically, the system of lava lamps is differential. So I'm claiming that Sky is still hackable. It's still hijackable. Can still interfere with it because it's right, but it's predictable because because of the places in some places at some time, but some places at some time some system. But what I'm really claiming is that it's kind of unsafe to not continue that way. So the kind of thing I'm saying is doesn't matter the lava lamp is because they're obviously set apart equally. Their ability is quite good. They can form a hypercube. And hypercube is really flippable. I'm not going to version of hypercube in hyperspace. Now, the hypercube represents hyperspace, like geometry we can see, but network geometry, this is not what we use but we can't see in our physical models. Like for example, you have a peer-to-peer network, but that peer-to-peer network is a simple model of a peer-to-peer network, but the other guy with the real one peer-to-peer network, which are basically the physical wires. So doesn't matter what the medium is. We said with the internet, you have a peer-to-peer network, and a peer-to-peer hyperspace is like one. So if you're sending from a computer, you're reading one transfer, but some things become some if something goes wrong or right, you can go to some cable infrastructure. There's no because sometimes you feel in the cases you understand that everything's not wireless at the moment. So you can understand that the person control system wireless wireless system, the cable, not transfer, transmitter, protocol, and get a wireless sense. So essentially it's possible to hide the system, hijack the system too. via hyperspace. Now, the hyperspace can be stochastic. So I would say that you have to say like in a cube, so you can have from with IP address format and format of an IP address. So I'm gonna have this model. So for the secret postcode, you have the MAC address, and for Mike, A for Alpha, C for Charlie, MAC address, which is the physical hardware ID. I have two IP addresses. So two IPVs. So you have a UUID, unique user identifier for a MAC address. So you have a system. But you're gonna have a MAC address and a UUID for that MAC address. You're gonna have V6. V6 is the latest one, I believe. But you know that gives you an alpha stamp. Well, which is called an alpha stamp. An alpha stamp is basically the hardware ID, which is called the MAC address. Now that UUID makes you unique for that model, make an kind of system. That's the UUID to do. You make a unique ID. So you get a UID V6, and you get a unique user identity V6. You're gonna have that stamp a model on a make of a computer onto a hardware system, so you get hardware ID. That's unique to every system on the network. Now you're gonna have two IP addresses. Now, two approaches basically are for readers. You can have IPv4 transmitter and receiver, but they are active to the IP at the system of transmitter. So they have channel 1 to 0, CH0 and CH1, and how this works basically is I'm trying to create a relay system to see whether this system can pick up my system. So if I have a GPS code that's latitude and longitudinal waveform, and try to see whether any leakage in the data, any leakage in the kind of data going through the other services, then that shows to me that the system can be hijacked via a relay system, because the system has to be maintained isomorphic. I'm busy. I am busy.
You've got social work to see you at 11 today.
My social worker.
For a care assessment, okay?
Okay. Thank you. You're gonna have this system here, relay system. So, the model you can. So, I'm going to draw it now. You have a market just gonna be. I'm going to try to draw it over here. You have I'm going to draw it. Oh, I'm trying to use this is the package to make it so. This is where this is a leakage in the network. You have some data that makes sense. Okay, so that you can relay that data via a measurement, a quantum measurement of systems. The paper's in there. Sorry, that's in my bag. So, like always, we have a peer-to-peer. So we have two key structures. For this to work properly, you're gonna have a hypercube. And hypercube is gonna have that. So you're gonna have a peer-to-peer topology, P2P, or end-to-end P2P. And this P2P is topology. You're gonna have a set. So you're gonna have peer-to-peer. You're gonna have a peer-to-peer. You're gonna have a peer-to-peer. You're gonna have a peer-to-peer. You're gonna have like a two sets of peer-to-peer. You're gonna have two sets. You're gonna have cable, and cable like a wired cable. You're gonna have wireless. And my claim is that the peer-to-peer topology is one network. There's one network. It's called hyperspace. So you're gonna have them operate in a kind of a combination of hyperspace. This model with the cameras there or not, you have a 3D world, a 2D world. So you're gonna have a cube. So this is square, but you're gonna have a cube from it. And when you're transmitting data, you have a hyperspace. You're gonna walk it over to the real world. So you're gonna have a hypercube. Because if you have a square, that means you're operating on a cube. So this is a hyper. This is a cube. This is a cube. This is a rectangle. A cuboid. But this is a cuboid. It's a 3D sphere. So you're gonna have a hypercube. So you're gonna have four. So you're gonna have wireless network in there. This is a topology system. But that's what I'm saying. So this is hackable because stochastic data is random data, but that noise is dissipates when the computer is stacked. So this is a conversation that doesn't really mirror the real world scenario. The real world scenario of the system, which is what's happening. They will align them in a nice fashion. if you had one lamp rotated, I'm saying to you, so I'm just solve my problem with my framework. So I'm trying to have a system for cloud fortification system, but they don't listen to me. I'm going to start doing it myself. So I'm going to have like my own lava system for NSIGII. We're going to have it in a kind of a circular way, kind of wind, different kind of motion. So it looks like let's stack. So let's stack. The more randomness you have, the more cases you have. This doesn't matter. This case is stochastic, it's predictable. The case is predictable. It's what I call predictable case. Yes, and so because the network transmits data, and this goes to a cable, and the cable captures it and gets it to another internet. That's how the network works. You have to go through it for everyone. That's the one why it goes or not. But it's not perfect. It's not perfect. So the array vector, if you have a vector array, array ID, and have an issue with her, I was using code Cloudflare, I have array ID error. That array ID error, I should never had that array ID error. That array ID error basically says you have convoluted browser. No. I know convoluted browser, but I go rerouted. So someone else you go rerouted to someone else's endpoint because you had a mismatch to his array. So because I had the old because my framework has changed. In kind of my second system, it changed for them. It didn't really affect them. So I'm saying, so let's go through watching the transcript video. Listen to this video. Basically, so that's just the point. So the point was that the goal is to have a system of non-reality, but this basically I read that. So I'm saying to you, the this is to have the IP address. So if you have a geo, you basically can tell if you can measure the real ID of Cloudflare IP address back to its own self. You really know it's coming from that something. The IP address is 1.0.0.1, and you can have a 1.1.1.1. And that's the IPv4 address. So basically, the type of you're going to try to measure. So if you have your look at it, you know there's no you, and because you just cancel that, you can measure this IP address. So the IP address said it's because the system is having some stochastic randomness, but that is not good enough to mask it. So if it's kind of hide itself, if I can pick the full address by connecting to the host, I should get the mask address of the Cloudflare server. So this IP address will give you. I'm using the system against itself, basically. I'm using the find the IP address. So if I get the actual Cloudflare IP address of Cloudflare.com, then I know that it's coming from the Cloudflare data centers, and that will show that it's proving me right. Cloudflare data center IP website. So So basically, the cloud data is you can Edinburgh Airport. Basically, saw in Edinburgh Airport, but it's not there really. It's not really there. It's gonna be somewhere. So this is for my research, my scientist, for Margoli, and basically, if I have the two masks address, I get two filters to mask. I choose to get the idea, two subnet mask. Again, the subnet mask, subnetwork mask. So those give I call it the hyperplane, and that will give me the IP address for the two system. But it's gonna work. So I'm so this basically put up the relay system I'm making is not for the Cloudflare hacking. I'm not going to basically for me to track myself as a GPS system, GPS tracker. So this is a global position for me. For me, so if I eat food well now, basically where I am moving around the world, with my own laptop, the food chases me. I don't chase the food. So if people follow the food, they're tracking me on the GPS. GPS system can make sure as I'm moving, they're able to come to me to move, like an Uber Eats driver moving to me, or like someone moving to me. Let's just finish this right now. Where's the video? Where's the Devil 2 article? I can't find it. So the Devil 2 article, I can't find it. So, yes, this is it here. So we're going to play it. Mm. So, essentially, that it's that's what I'm saying. The goal of basically is not to hack into it, I'm trying my own kind of system to set up this, for NSIGII, and so I said you got you forgot idea. It's a human rights protocol, give you food, water, and shelter. It's basically the problem is literally natural. So you have to do digital systems, because it's gonna work with email, it's gonna work by phone, it's gonna work by having SMS protocol, it's gonna work by SMTP. So you're gonna have by phone, have a phone call, gonna have a phone call, gonna have an email system, and you're gonna have an SMTP, gonna have a system of a phone call, email, phone call, like phone call. There's a it's for SMMT, which is an email system. Simple form plus a phone call or SMS, simple SMS SOS system, a simple message system, which I believe is called. I'm gonna have email phone. We're gonna have a Wi-Fi call like WhatsApp or something, digital like voice over IP or like a video over IP or infrastructure for Instagram, But we have three things three kind of for electrical magnetic system. But the goal is to have something that's unilateral and a consensual kind of have keep because it doesn't need to have a bandwidth to it needs to work on cable, it can work on wireless. This is going to be a bypass digital system that works together. Because, they don't need to interfere with each other. So if a communication is pending, pending one system, use other system free of charge. I've used the hacker have to, but this is it's a little queue. That's what happens to a little queue in the kind of digital system. You can use a phone to do it. You can use an electric phone. You can use a phone to do it. You can use a wide phone. So let's go here. So this normally you have assigned numbers to the nodes of the system. So you have the system. So if it's a physical mark, you have a physical mark. If you have a virtual mark, so you have a virtual. So for your own system, so every system has a virtual mark. So my IP address is um so my IP address is 198.168.0.1. That's my IP address on the internet. Now my local my address is F216 colon 212CB colon IG no G no what's the F216 colon 12CB colon ABC 2 colon RIFFC. So this is my IP address here. This is my MAC address here. Now my machine have two. No, my MAC address has two. I have two MAC addresses here. So that's one MAC address. I have a relative MAC. So this is my absolute MAC address. And my relative MAC will be this is my physical MAC address. Then I have a hardware address. So my other MAC will be my two virtual MACs, especially my two IP addresses. So this is my first IP address here. So I have to have another MAC. So my IP address is 198.168.0.1. I have another IP address called 198.167.0.1. Okay, 198.168.0.2. So these two MACs can make a virtual MAC now. I have a virtual MAC address and a two, but that's a distro, that's operating in the distro fashion. So I can trace my position in the real space. That's my goal. Via the space or tag, via the GPS model. So GPS model is gonna have a model of this. So model system, this is a track. So how do you track it? So basically, I'm trying to have a Go package. So in NSIGII.go, you're gonna have my MAC called LT, which stands for linkable DAN. LT package. So this is called LT because it's linkable DAN format. It's not NSIGII bound, but it's just one package of the system. Obviously, so you have NSIGII LT.NSIGII, but this LT.NSIGII, you can have linkable DAN executable or linkable DAN something. Based on Apple, but this is codec system. This is codec system for this. So LT, let's call it linkable DAN. LT, NSIGII linkable to LT, linkable DAN codec, LTC package, into LTC, linkable DAN codec system, coder decoder, linkable DAN coder decoder, codec, LTC, LT codec. So let's call it LT codec.go. The package there. So this can have the model of trying to have a kind of a dual system, like operates kind of a system. So you can have so if you have 198.0.1, you can have 198.0.1 and the ports to the wire interface. Again, the ports can be port markets, it can be system that as long as they connect, and they do the broadcast, as long as they do the sending, as long as they do the sending and receiving of the recipient and send via the loop MAC address. So of longitudinal wavelength, 2.5 of the system, to the half ratio, so half of rotation, half rotation, and then double the scale, double the bandwidth, half the enlargement of the scale, and then double the bandwidth, half for translation, double the bandwidth, half transformation, half dilation, double the enlargement, of the magnitude of the so you can fix up to some system via the kind of Forensic model. Thank you for watching the video. This is